Dear good student, today we will start new topic. This is crystal field theory. So crystal field theory tells that your metal ligand bond is truly ionic. And ligand they have divided into two parts. Ligand is either anion or ligands may be your neutral. So neutral ligands, they are called, that one is a dipolar. For example, if I take H2, so this is positive, negative, positive. So that makes it is a dipolar, positive and negative. And anion ligands are there. We have Cn negative. This is the anionic ligands. So when the metal ligand bonds takes place, the bond is truly ionic. It is like that. Or if it is a neutral molecule, it is plus minus sharing of some charges are there. Now, this theory tells that when, for example, this is your metal ion having 5 d orbitals. I'm drawing here, it will be better. This is the 5 d orbitals of a metal ion. This is d xy, dyz, dzx, dx square minus y square, and dz square. When ligands approaches towards them, ligands having its own electron, there is some electrons are there. So like charges, we know that the like charges will repel. So these electrons, there is a repulsion. Due to this repulsion, the energy of all the 5 d orbital is lifted. After that lifting of energy, they split up into two parts. We are doing octahedral splitting. They split up into two parts. This is your lower part, it is called T2G. This is the higher level, is called EG level. And this line is called your very center. Now the energy gap between these two is called del O. For octahedral splitting, it is del O, where del O is called crystal field splitting energy. Del O is crystal field splitting energy. The higher one is 0.6 del O and lower one is minus 0.4 del O. Now 0.6 into 2, this is 1.2, and minus 0.4 into 1, 2, 3, this is also minus 1.2. So this thing become equal to one another. This becomes in the neutral energy. Now the question arises is that sum of the d orbital, these are the 3 d orbital, this is the dxy, dyz, dzx in the lower level, and this is dx square minus y square and dz square in the higher level. The question arises, why the sum of the orbitals in the lower level and why the sum of the orbitals in the higher level? Now that question, actually when the metal is there, in octahedral splitting, the ligands are approaching along the axis. The ligands are approaching along the axis. This is the x, this is y axis, Axes are like that: x-axis, y-axis, and z-axis. When ligands are approaching along towards the axis, so there is a repulsion between the orbital that is present in the axis with the ligand maximum. The orbital present in the axis is your this one, dx square minus y square and dz square. This is dx square minus y square, and this one is dz square. So obviously the ligands which are on the axis repel more by the orbitals which are on the axis repel more by the ligand, and orbitals which are in between the axis, for example dxy dy, repel less. That is why due to more repulsion we know higher energy, so that is why dx square minus y square and dz square in the higher level, and dxy dy is in the lower level. So this is what is the crystal field splitting in octahedral complexes. Now we are continuing with this one again. One, two, three, four, five. 1, 2, 3, 1, 2. Now this is your del O. And another point, student, I want to tell you that this is pairing energy. Now energy required to paired up electron in an orbital. Its first electron is already present there. If you want to add the second electron, then there is a repulsion from the first electron, and whatever may be the extra energy required to pair up an electron. Now if a system 2, 3, just I am drawing this level one, 1, 2, 3, 1, 2. Now if you have D4 configuration, then electrons are distributed like that, 1, 2, 3. Now question about the fourth electron. Now if this is your del O value, if del O value is more than pairing energy, means energy required to paired up electron is less compared to the energy required to promote an electron in the higher level, then what happens? Pairing will take place. This is the condition 1. For D4 configuration again, if 1, 2, 3, 1, 2, this is del O value. Now del O value is less than P. So 1, 2, 3 electrons are there. The fourth electron goes where? Fourth electron goes, because del O value is less than P pairing energy. So wherever may be the minimum energy, it will take the minimum energy path. So it will goes to the higher level. So this is what is called, what we have crystal field splitting in octahedral complex. So next class will take that one, tetrahedral complex.